Here we want to carefully graph and shade the region enclosed by these curves. So we look at these curves. This first curve is a parabola. We have a negative x squared, so it opens down, but the 4 makes it move up 4. So we got up 4. I'm going to do over 1 and down 1 on either side, and then over 2 and down 1, 2, 3, 4 on either side. I'm going to do it one more time. Over 1, 2, 3. 3 squared is 9, so down 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we've got the corresponding piece on the other side. So our parabola looks something like this. And now we look at the other equation and we see we have a line whose y-intercept is 4, whose slope is 3. So we'll go up 3 over 1. To get more points on this line, we're going to go down 3 into the left 1. We'll do it again. Down 1, 2, 3 into the left 1. Let's do it one more time. Down 2, 3 into the left 1. So here's our line. And so our area between the curves is this region right here. Now let's go ahead and algebraically calculate the intersection points. Looks like we've got them, but let's confirm that. So we want to figure out where the two equations equal each other. So I'm going to put those equal to each other. I'm going to move things over to the left-hand side. Actually, the 4's are just going to cancel. If I move the x squared over, I'll have plus 3x equals 0. So I can factor out an x. That'll leave me x plus 3 equals 0. So either x equals 0 or x equal negative 3. Let's find the actual points. So if I put 0 in, I put it in either function, I will get 4. So one of the points of intersection is right here at 0, 4. And then if I put negative 3 in, I would have negative 5. So our other point of intersection is negative 3, negative 5. So now we want to calculate the area between the curves. So we're going to do an integral, and we're going to go from our 2 points of intersection. So negative 3 for the x to 0. We take the upper curve, that's the parabola, so 4 minus x squared minus the lower curve, the line. Make sure the negative gets distributed to both pieces, dx. So this will give us our area when we compute this integral. Let's do the antiderivative. So this is going to be, actually let's cancel our 4's. Now we'll do the antiderivative, which will be negative 1/3 x to the third, and then we've got negative 3/2 x squared. Evaluate from negative 3 to 0. So as we do our evaluation, we would do f of 0 minus f of negative 3, and we see when we put 0 in there that we get 0. So we have 0, and then putting in minus, we need to subtract the lower limit, so that'll be minus a minus, make it a plus. And then we're putting in negative 3 and cubing it. Then we got minus a minus for a plus again. 3/2, putting in negative 3 squared. So let's go ahead and simplify this. I have negative 3 cubed, which is negative 27, divided by 3. That will make negative 9. Here I have negative 3 squared, which is 9, times 3, which is 27, so plus 27 halves. So we'll make that 9 into halves, negative 18 halves plus 27 halves, and that will give us our area between those two curves, which is 9 halves.